Hello, my name is Dallin Thewison,
I'm Kent Charrington.
This is Logan Waite.
and today we're going to be talking about Lesson 11 group problems.
Yeah, so on question 1 it says, this question concerns the molecules involved in translation. Part A asks, indicate the group of enzymes that covalently link amino acids to tRNA molecules. So as you remember, when it combines to the ribosome, you got your tRNA molecules, your aminoacyl tRNA synthetases.
That word.
That one. You have those molecules, and so that's what we have here, the aminoacyl tRNA synthetases that compact with the amino acids connected to the tRNAs. Okay. So then part B asks, indicate 4 proteins that consume GTP during translation. We have the IF2, IF3, EFTU, the RF. Is that RFI 1? Yeah, I'm guessing it's 1. And then RF2 and EFG. So all those are just kind of like the different the factors that help with the translation. Part C asks, indicate 1 molecule that functions as a ribosome during translation. That's the 2,3-S RNA molecule. D, indicate 2 proteins that recognize stop codons. We put RF1 and RF2. For part E, it says indicate 1 molecule that forms hydrogen bonds with the Shine-Delgarno sequence in the mRNA, and that's the 16S rRNA. Okay, so as we continue on to question 2, these are other just kind of definition answers. For part A, it says the first amino acid in prokaryotic proteins is N-formylmethionine. Part B, it says E. coli protein called EFTU delivers charged tRNAs to the A site of the ribosome during translation elongation. Part C, the initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNA binds to the A site of the ribosome. D is the EFG is a translation factor that helps the ribosome remove 1 codon in the 3' direction along the mRNA. E, the IF3 is a translation factor that guides to the mRNA to the 30S ribosome subunit.
Okay, for part F, the AUG codon is the start codon, while UAA, UAG, and
That's a G.
It's kind of cut off right there.
That's a UGA.
UGA, sorry.
UGA are the stop codons. And the degenerate is a term that indicates that more than 1 codon can specify the same amino acid. For part H, the final amino acid is located at the C terminus of the polypeptide. In question 3, it asks us, it gives us a series of RNA codons, and it asks us what the possible anticodon sequences are, considering the Wobble rules. So for part A, it gives us the codon UUG, and the possible anticodons are AAA, AAU, and AAC. In B, it says the codon is AGU, and the possible anticodons are UCU, UCI, UCG, and UCA. Part C, UAC. The possible anticodons are AUI, AUG, and AUA. In part D, it gives us the codon AUU, and the possible anticodons are UAU, UAA, UAT, and UAG. And finally, in part E, it asks us for the anticodon of GCA, which include CGI and CGU.
I was doing these right. Mm-hmm. Okay. All right. So then on question 4, it says suppose the E. coli contains a protein called protein X, which is 218 kilodaltons in molecular weight. So for part A, it asks if the average amino acid is 125 daltons, how many amino acids are found in protein X? So simply, we just take the total number of daltons, which is 218,000 daltons, and times it by 1/25, or just divide it by 125, to give us a total of 1,744 amino acids. Okay, so for part B, it asks what is the length of mRNA coding region, for example, like the portion of the mRNA that encodes the amino acids responsible for producing protein X. And so we take the total number of the amino acids and we times that by 3, which gives us 5,232 nucleotides long. Okay, so then part C asks how many GTP molecules are consumed to synthesize each copy of protein X. So for each copy, it takes 2 GTP. So we times that by the total number of amino acids, and then we add 1, and that'll give us 3,489 GTP consumed.
So for part D, it asks how many ATP molecules are consumed to synthesize each copy of protein X. And so that we know that 1 ATP is used for every single amino acid, and so just based off of our answer from A, we can conclude that 1,744 amino acids will take 1 ATP, or 1,744 ATP for that. And then for part E, it asks what is the name of the group of enzymes that consumes ATP to assist in the synthesis of protein X. And we know that to be aminoacyl tRNA synthesis. I can't even say that word.
Such a hard word.
Okay, so for part 5, we have a list of different proteins and nucleic acids, and we're supposed to answer these questions and which ones kind of relate to each question. So which of the above is involved in translation initiation? So initiation is when it just starts. And we know that tRNA, FMET, IF2, IF3, 16S rRNA, and Shine del Garno, those are involved with the translation initiation. With part B, which of the above is involved in the translation elongation? And this is 16S rRNA, EF dash, I don't know how you say that, it's like 2 or 2U, and then EF-G and 23S rRNA. For part C, it asks which of the above is involved in translation termination. So this is going to stop the process, and this is the 5' UGA, 3', and RF1. And then for part D, it says which of the above is a component of the 70S ribosome, and we know that to be the AUG sequence, as well as the 5' UGA and the Shine del Garno. And then I believe that's all of them. So thank you for watching our video, and have a wonderful day.